Hello and welcome to today's screencast. Focus is on exercise at heat. So specifically in today's screencast we're going to look at the effects of exercising at heat on the cardiovascular and respiratory system. Now within this and specifically within the cardiovascular system we have to have an understanding of two heat-based conditions: temperature regulation and cardiovascular drift. Now before we go in to the details on the effects of exercising at heat, I think it's really important to have some foundation knowledge. So first thing that we need to know is to have an understanding of core body temperature. Now core body temperature, or an average core body temperature, will be in the region of 37 degrees Celsius. Now it is normal to have a fluctuation of your core body temperature by 1 degree up or down, and as we are focusing today on exercise at heat, 1 degree up. Now obviously that is normal, that is an average core body temperature. Our focus today is going to be having a look or investigating the acute effects of exercising at heat on our core body temperature, and then the knock-on effects from that. So I'm sure you can kind of work out that when you are exercising at heat, this can have an impact on our core body temperature by increasing it above that 1 degree fluctuation that would be considered normal. Now when we exercise at heat and our core body temperature goes up, this can have really quite extreme implications on our cardiovascular and respiratory systems. Okay, so what we're going to have a look at in the next couple of slides then is we're going to look specifically at how the cardiovascular system and the respiratory system are affected. Now I think it's really important with regard to your exam technique that when you consider the implications or the effects of whether it's exercise at heat or altitude last lesson, when you consider the effects of an environmental condition on the cardiovascular and respiratory system, it's important that you segregate your knowledge. Okay, so what you need to have an understanding of whenever we are talking about the effects of an environmental condition on the cardiovascular system, we have to split up the cardiovascular system. So we need to remember that the cardiovascular system consists of the heart, blood and blood vessels, and if we remember that, this really does help us to ensure that we are going to get onto the mark scheme when we're answering questions, and I'll talk about that in the lesson. On top of that, when we're looking at the implications on the respiratory system, we need to look at how the heat is going to directly impact our breathing, okay? And then from that there will be knock-on effects with regard to performance. So I think that's a really important introductory slide to set the scene on where we're going, important information on core body temperature. So now let's go in and have a look specifically to start with on the cardiovascular system. Okay, so two things we have to look at which will allow us to see numerous effects of exercising at heat on the cardiovascular system. The first thing we're going to have a look at is something called thermoregulation. Now in order to make sure we have a full understanding of this, we need to make sure we can answer these key questions going down here. So to start with then, what is thermoregulation? So thermoregulation refers to the process of trying to maintain core body temperature. Okay, so it's our body when it notices that we are getting hotter, it is our body trying to self-regulate our temperature. Okay, so why does it happen? So if we consider now when might this happen, why does our body thermoregulate? It happens due to thermoreceptors detecting an increase in body temperature when exercising at heat. Okay, so that's why thermoregulation happens. Now what is most important with regard to your subject knowledge, if this is the basis, this is the foundation in terms of the actual application, if we're at exercise, our body is trying to thermoregulate itself, okay, to try and maintain that 37 degrees C. This process starts via the receptors, thermoreceptors detect an increase in core body temperature. Now the effect of this is when we are exercising at heat, this will cause vasodilation of arterioles supplying the skin. Okay, now you will know from previous study that vasodilation means that the arterioles are going to open or widen, which allows a specific effect. Okay, so supplying the skin, those vessels there open up, and this then causes an increased blood flow to the skin, which is released via sweat, which allows heat to be released via sweat, but it can lead to dehydration if you do not replace the excess water that is lost. Okay, so I think that hopefully you can see exactly how that works. Now, on the previous slide I said the cardiovascular system consists of heart, blood and blood vessels. Specifically here we've looked at how thermoregulation, the process, the effect of thermoregulation is that it causes vasodilation of arterioles supplying the skin, which is a blood vessel, okay, which then allows the blood to flow out towards the skin, which allows us to sweat, to release heat, but it can lead to dehydration. Now, once we've got that concept, what I think is really, really important is, yes, thermoregulation has done a job to help us, to try and maintain our core body temperature. But what we have to consider here is our topic is referring to exercise at heat. So there are certain implications now. Your previous study, you looked at vascular shunt, okay, and the redistribution of blood flow to the working muscles during exercise. Now, heat and thermoregulation causes us a problem, because rather than when we're exercising at normal conditions redistributing to the muscles, now we've had a redistribution of blood to the skin, which obviously is going to have implications for the blood flow to the working muscles. So I think now it's really important to just make a note of the implication, because this will help us when we move on to our second effect of heat, exercising at heat on the cardiovascular system. So if heat is being removed by the blood to the skin via sweat, what happens to the blood flow to the muscles? Now, obviously, blood flow to the muscles is going to decrease, okay, because the majority of the blood and the water within the blood plasma is switching towards the skin, so we can release heat. So if we go from here then, I think this implication here, we're going to come back to it in a second. Hopefully it will make a lot of sense to you when we go on to our next effect of exercising at heat on the cardiovascular system. So, next thing we have to look at, and you remember it from the previous specification slide, we have to look at something called cardiovascular drift. So if I could just ask you to imagine now drift as a kind of an upward movement. So cardiovascular drift refers to an upward drift in heart rate caused or linked to an increased body temperature. Now, what we have to know, it's not enough for us just to say that, cardiovascular drift, upward drift in heart rate caused by an increased body temperature. That isn't enough. We have to know why there is this sudden spike in heart rate when we are exercising at heat. Now, what happens, and you will remember this process from when we did altitude, the reason why heart rate increases when we exercise at heat is because there is a decreased stroke volume. Now, this decrease in stroke volume is caused by a decreased blood plasma volume, which directly links to what we talked about over here. So if I just put this into process now, okay, when we are exercising at heat, okay, we have a decreased blood plasma volume, okay. This means there is less, because of the water within the plasma moving to the skin, we have that's reduced. This causes our stroke volume to decrease. Now, when our stroke volume decrease, this then causes or stimulates our heart rate to move up. And as we will remember, the reason why our heart rate increases when our stroke volume and blood plasma decrease is to try and maintain cardiac output. Now, this is unsuccessful. Why? Because if we have a decreased stroke volume, we have an increased blood plasma volume, this means we get less oxygen, less blood to our working muscles. It also means that because we get less blood out, we also get a reduced venous return. So all of these things working together stop us from maintaining our cardiac output. So if we see it like this, I'll go through that one more time. Cardiovascular drift, upward drift in heart rate. Why do we get that spike in heart rate? Because stroke volume decreases due to blood plasma volume to try and maintain cardiac output. It can't, because there's a reduced or decreased venous return, which stops the blood coming back in the first place. Okay, so these are the kind of knock-on effects that really, really put an excess strain on our cardiovascular system. So if you put it down to here, and I've said onto here, this whole process directly links to the implication that I put over here. Okay, there is an increased blood flow to the skin, which is released via sweat. So I thought it was useful putting that in. This then causes all of these problems to start, because if there's increased blood flow to the skin, this reduces the blood plasma volume. Okay, if the blood plasma volume is reduced, this decreases the stroke volume. That causes heart rate to increase to try and maintain cardiac output. But it can't, and this also, because it can't do that, another knock-on effect of that is there's a decreased venous return coming back, which means we can't get the blood out, and it comes in like a vicious circle that stops us from being able to perform at our maximum during exercise at heat. So if we go on from here, what is the effect of this? Okay, well, if we consider now, always, if we know we can't get the blood back, if we know we can't get the blood out, okay, we know that we've got a problem, because we rely on our stroke volume and our cardiac output being high in order to get blood to the working muscles. So the net effect of this is there is a reduced oxygen transported to the working muscles. Okay, so this is the net effect of all of this. We cannot get as much oxygen to our working muscles to allow us to perform effectively aerobically. Okay, so that is our key section there. That is the impact of performing at heat on the cardiovascular system. So now let's have a look on to our next slide and start to consider what might happen to when exercising at heat on the respiratory system. So if we go on to here then, now what we need to do is just consider, we're going to start off, so when we perform at heat, it has an initial effect with regard to our respiratory system, and it's directly linked to dehydration and the drying of our respiratory airways. Now, when this happens, when we are dehydrated, when our airways dry, this has a knock-on effect, and the effect is this: there is a constriction of the respiratory airways, and because of the dehydration and the drying of the airways, it will lead to mucus production. So if you imagine what that looks like, if you've got a normal lung airway here, and then you've got one with mucus on here, as you can see, this is an example. If that is maybe a vasodilated airway, this is what would be called a constricted airway. So the constriction is caused quite a bit by the mucus that accumulates here. So because of this, a constriction of airways, mucus production. Now I'm sure you can imagine, what does that mean? With regard to respiratory system, we want to breathe, okay? We want to breathe in, particularly oxygen. So what happens? This causes, due to the fact we have a closing of our airways due to mucus production, this means there is a decreased volume of air inspired. Okay, now what this means, okay, so we get less air going in. This means that we have to increase our breathing frequency to try and maintain oxygen consumption. So if you consider that now, we're getting less volume of air in. So suddenly we have to try and increase the number of times we breathe to try and maintain that oxygen consumption. Now, when we consider it from there, this links to another effect, okay, and it's called this. It leads to an increased oxygen cost of exercise. So if we are having to breathe more often for the same oxygen consumption, the cost of this oxygen is increasing. Okay, so I've put it onto here. So when exercising at heat, you have to breathe more often for the same oxygen consumption. So the oxygen costs more breaths than it would if you were not exercising at heat. Okay, and then to finish that off, what does that mean with us in terms of a net effect? This is going to again reduce oxygen transport to working muscles, which will then decrease our aerobic performance as a net effect. Okay, so hopefully you can see how that happens. So we're starting off here, dehydration and drying. That causes the constriction via mucus production, and then the volume of air decreases going in there. That means that we have to breathe more often to get the same, or try and maintain oxygen consumption, which increases the oxygen cost. Okay, so that's what we're looking at for that. That's the process and the net effect down here. Okay, please make good notes on these. Okay, thanks very much.